Hey and welcome back to this next video. In this video we are going to talk about the solution process, and we will also mention solvation and dilution within this video. In the last videos we already learned about the basic definitions of solutions, and we learned that solutions are homogeneous mixtures. So mixtures that if we look at them with our eyes, we cannot distinguish the different parts of the mixture, right? So what are parts of the solution? A solution is always consistent of a solute and a solvent. The solute is always the substance that is in smaller amounts compared to the solvent. So the solvent is a substance in the solution which is present at a higher amount. A good example here would be the solution of salt water, where we have a solute, the substance in smaller amount, in our solvent, which is our water, forming the solution of salt water. Another solution that we can take, for example, is blood. And in blood, the most abundant substance is water, so our solvent will be the water, and our solutes within the blood are multiple. We can have red blood cells, white blood cells, platelets, proteins, and a lot more. And these will then form a multiple solutes within our solvent of blood. Also important for you to remember and to recognize is that solutions do not have to be in liquid form. Solutions can exist in all phases of matter. For example, over here we have the example of air. And in air we have a solvent is a nitrogen. As you know, the most abundant gas in our air that we're breathing is nitrogen. And the second most, let's say, is oxygen. So this would be our primary solute. Of course, there are also other gases within air that are also solutes, but this is just for you to remember that solutions can exist in all phases. Now, how actually is a solution formed? We call this the solution process. And I just want you to know that a solution is actually not a chemical reaction. It is a physical change, and this physical change follows some specific rules, and we just summarize those rules in the saying like dissolves like. So we say those are two basic rules that polar compounds like to dissolve polar compounds. So polar compounds like to form solutions with other polar compounds, while non-polar compounds like to dissolve and form solutions with non-polar compounds. So let's take a look down here. We have two polar bears, and those polar bears are now illustrating polar compounds. In the last video we learned what polar compounds are, and you can just go back to that video as a quick reminder. And as you can see here, those two polar bears are like each other and therefore would like to form a solution. The same goes for those panda bears over here, and panda bears, as you know, are not polar bears, so they are illustrating non-polar compounds, and they also want to form solutions together. This is different when we have a polar bear and a panda bear, so a non-polar compound and a polar compound. Here it is not possible for them to form solutions. So how does actually the process of forming a solution look like? There's also a synonym for this, and this is called solvation. So solvation is a kinetic process, and we said that it's not a chemical reaction nor a chemical process, but a physical process. And what is going on there is that we have the molecules of the solvent, so the compound that is more abundant, that are surrounding our solute particles and therefore forming a homogeneous mixture, a solution. Okay, this right here, this big crystal over here is salt, sodium chloride. The big yellow blobs here are our sodium, and the smaller ones here are our chloride. If we now drop this crystal into water, you can see that the water molecules are trying to surround these particles of our salt over here. And you can see that they interact in a very specific pattern. So these four water molecules here want to interact with our big blob here, the sodium. And you know that sodium is a cation, right? So it's positively charged. In the last videos, we learned about polar compounds, and we learned that water is a polar compound. We learned that due to the structure of water, on the side of the hydrogens down here, there's a relative deficiency in electrons. You know, hydrogens only have one electron and oxygen has 6. So if we take a look at this geometrically, on the side of the oxygen we have more electrons. Therefore, it will have a dipole formed like a magnet being negative. And if our sodium over here is positive, they are attracting, right? So this is where we have our 4 water molecules here attaching to this sodium over here due to their dipole interactions, our intermolecular forces over here. And this can then be extracted from our crystal. How does it now go for a chloride? We also want our chloride to be a solution in our salt water over here. We also have our water coming to surround our chloride over here. And as you know, chloride is an anion. And here we have a different distribution of our water. The water here is now trying to attach with its hydrogen side, because of course the hydrogen side is more positive and would like to be in close contact with the negative part of our chloride over here, as it is an anion. And this will then also be somewhat, we can imagine it, lifted outside into the solution. And we will now just do this a lot of times until all the salt is completely dissolved, completely dispersed in our solution, and around all of those particles you can see these water molecules are surrounding in a specific pattern. So now we also have to talk about a very specific concept of saturation. If we have a specific amount of water molecules, of course, we can only surround a specific number of solute particles. And this is the process of saturation. A synonym for forming a solution is also dissolution, so the process of dissolving a solute within a solvent. And the opposite process is the crystallization. There are actually three types of saturations within our solutions. First one would be the saturated solution. In a saturated solution, we have this state where we have almost the perfect amount of water molecules, in our example, for our salt. So there is enough water to dissolve all of our solute particles. And this is what we call a saturated solution. And in a saturated solution, we have some sort of equilibrium within our crystallization and dissolution, and only a very small amount of our crystalline salt can stay or will stay at the bottom of a solution, because we have almost the perfect amount of water for our crystalline structure, our solute, our salt here. So as you can see here, the blue arrows are denoting the dissolution process. And then there are also the other way. This is the crystallization process, and this is denoted as this smaller orange arrow over here. And in the end, we have some sort of equilibrium where crystallization and dissolution process are matching. And in saturated solutions, we only have a very small amount of crystallized substance on our bottom. Another way is the unsaturated solution, a solution where we have less solute and a lot of solvent. So the solute can completely dissolve and we are not leaving remaining solute. So we could even add more of our salt and we would have enough water to dissolve everything. So you can see that in the end here, there is nothing of our solute left in a crystallized form on the bottom. The last one is the supersaturated solution, where we have so much solute that we do not have enough solvent, so not enough water in our example, to dissolve all of those particles. And this can be seen here, right? Another important concept to mention is the concept of dilution. And dilution is the process of adding solvent to a solution. So in our example, we have our solution of some concentration of salt within water, and then we add more water. And this, of course, then will decrease the concentration of the solute. And therefore, we have this wonderful dilution equation. And with this dilution equation, we can determine the initial volume and concentration of the solution, and we can also determine what is the concentration of our solute after we have diluted this solution. So, for example, here we can see that we have initially some amount of water here, and in the second one we added more water, and now we want to know what are actually the concentrations of our solutes in here. So let's take a look at some examples. So we have the question that what is the final concentration if 75 milliliters of a 3.5 molar glucose solution is diluted to a volume of 450 milliliters. So over here in our first class, we have 75 milliliters of water, and we have a concentration of 3.5 molars of glucose. We will talk more about this denotation of concentration in later videos. It is just important for you to remember now that this is a measurement of concentration. And now we are adding so much water that at the end we don't have 75 milliliters, but we have 450 milliliters of water. And the question is now, what is now the concentration of our glucose here? So let's plot in our numbers. Our M1, so our concentration in our glass 1, is 3.5 molars of glucose. And our volume 1 is 75 milliliters. Of course, we have to calculate in liters, so this would be 0.075 liters. And our volume 2, we know that because we're diluting it, we have 450 milliliters, making 0.45 liters. Now let's take a look at our dilution equation, and we know that we are looking for M2, the concentration 2, and if we pop our values in, we have 3.5 times 0.075 equals M2 times 0.45. And then of course normally we will divide by 0.45, and this will then give us 0.58 molar concentration of glucose in our secondary diluted solution over here. Below this video, you will find some examples to calculate, and important for you, you will always have at least 3 values here given to make your calculation possible. To summarize this quick video, we said that the solution process has a rule, and this rule is like dissolves like. Polar compounds like to dissolve polar compounds, and non-polar compounds like to dissolve non-polar compounds. We said that there are types of saturations. We can have a saturated solution where we have almost the perfect amount of solute for a solvent, and only a very small amount actually stays in its crystalline form on the bottom. Then we have unsaturated, where we have so much solvent that we could dissolve even more solute. And then we have a supersaturated solution where we have so much solute that a lot of it will actually precipitate and stay on the bottom as a crystalline structure. And the dilution equation is M1 times V1 equals M2 times V2, M being the concentration and V being the volume in liters. Thank you for watching this video. Below this video you can find some examples and questions, and then I will see you in the next one.